Hi everyone, Mrs. Venti here. In today's video, we are still busy in equations, and today we are going to look at simultaneous equations. This video is going to cover example 11 and example 12. All right, so example 11 is a revision of linear simultaneous equations, which is what we did in grade 10, and we are given two equations. So there's different ways of doing this. Let's see how many ways we can do. So let's write our first equation as 2x plus 3y equals negative 2, and we name this one a. Then we can write x minus 2y equals 6, and we name this one b. So we've got two equations. What we're going to do is, the most common way is to write one equation in terms of the other, substitute, etc., etc. So we can now use equation b and take this over and say x is equal to 2y plus 6. Now I am going to substitute b into a by saying 2, and this is b, right? So instead of x, I'm going to write 2y plus 6 plus 3y is equal to negative 2. Now the whole equation is written in terms of a. And we can name this equation, or let's solve it and then we'll rename it. So 2 times 2 is 4y plus 24 plus 3y is equal to negative 2. Okay, so that is 7y. We can take this 24 over, if you don't mind me doing it in the same step. 7y plus 24 equals negative 2, and then minus 24 both sides. So 7y is equal to negative 26, if I'm not mistaken. No, I am mistaken, because I multiplied by 4 and I should have multiplied by 2. So it's 12. Yeah, okay. I thought the numbers weren't working. Okay, so that becomes negative 14. Okay, once I've done that, I can now divide by 7 on both sides. And this means that y ends up being equal to negative 2. Now I've got the value of y, and I can name this one c. And I can now say, okay, substitute c into, now I can choose either equation, it doesn't matter which one. I'm going to use b. And I am going to now write x minus 2 times y, and y, according to c, is negative 2, equals 6. So x plus 4 equals 6, minus 4 on both sides. So x is equal to 2. So now I've got the two values that says x is 2 and y is negative 2. This is one way of solving simultaneous equations. Write everything in terms of one, use one equation, write everything in terms of one variable, substitute it into the other formula, get an answer for the second variable, and then take that second variable, substitute it in a or b, whichever one is easier, and get the first variable. Another way of doing this is by subtraction. So let's use the exact same ones. I know you can't see it, but I've got it. Okay, so we're going to say 2x plus 3y is equal to negative 2, and we name that one a. And we say x minus 2y is equal to 6, and we name that one b. So what are we going to do? We are going to say multiply b times negative 2. Okay, that means that this becomes, I'm going to rewrite everything, 2x plus 3y equals negative 2. That's a, if you remember. Now I'm multiplying everything times negative 2. So minus 2x plus 4y is equal to negative 12. Okay, once I've got that, so this is now minus 2b, if you remember. Okay, so now we're going to subtract or add them up. Minus 2x plus minus 2x is 0, so my x's are gone. 3y plus 4y is 7y is equal to negative 14. And then divide by 7 on both sides, which means that y is equal to negative 2. Exactly the same as that on the top. Once I've got that, I can then substitute it into the formula. So I repeat this whole thing there. Yeah, I substituted it into B, but let's substitute into A and see if we get a different answer. So if I have 2x plus 3y equals negative 2, and I want to substitute y equals negative 2 into this equation, I am going to say 2x plus 3 times negative 2 is equal to negative 2. So now I say 2x minus 6 is equal to negative 2 plus 6 on both sides. So that's gone. 2x is equal to positive 4. Divide by 2, divide by 2, x is equal to 2, which again is the exact same answer we got on the top. So simultaneous equations, a couple of ways of doing it, all of them are correct. That's example 11. Linear and linear. Write everything in terms of one variable, substitute it into the second formula, calculate that variable, substitute it into one of the two formulas, calculate the second variable. Let's look at example 12. Now, example 12 is a situation where we have a quadratic and we have a linear. So let's rewrite it. We're going to say y is equal to x squared minus 1 and name that one A, and y minus x is equal to 5 and we name that one B. So what are you going to do? Same thing you do with linear. Write everything in terms of one equation. So on B, I'm going to write y is equal to x plus 5. That's where I start. Okay. Now I'm going to substitute y equals x plus 5 into A. You can actually say B into A, whichever way. It's fine. Or you, whatever. Doesn't matter. So now I'm going to say y, which is now this y. I'm going to write that. X plus 5 is equal to, rewrite that, x squared minus 1. And I am going to solve for x. Now I notice x to the power of 2, x to the power of 1. So everything on one side. So that means that 0 is equal to x squared. Take this over, minus x. Take this over, minus 6. Now I'm going to solve, and I'm going to say 2 brackets. X and x, I want, okay, I want the factors of 6 that give me 1, so 3 and 2 will give me 1. I want a negative 1, so negative 3 plus 2 gives me that. This means that x is equal to 3 or x is equal to negative 2. Okay, so I've got 2 values for x because it's x to the power of 2. This makes sense, right? Okay. So now we are going to substitute those values. So now I'm going to say substitute x equals 3 and substitute x equals negative 2. So y minus x equals 5. Or you can use this, either one is fine. Y minus 3 equals 5. Y is equal to 8. That's our first value, which means I've got an x value and a y value. These two give me the coordinates 3, 8. And if I substitute x is negative 2, I can say y equals x plus 5. Y equals negative 2 plus 5. So y is equal to 3. Again, I've got two coordinates, which are going to be negative 2, 3. What does this mean? In terms of a sketch, what does this mean? If I was to draw a sketch, then I would have, first of all, I would have this equation, which cuts at positive 5, y is 5, and it would look something like that. Okay, let's assume it's cutting at y is 5. Then I have this equation, which is going to have two intercepts on the x-axis, but I don't know what those intercepts are. What I know, these coordinates is where they cut the linear graph. So there's going to be a point where if this is 5, then it must be higher. So let's make that one 3, 8, positive 3, positive 8. And then we're going to have another one which is going to be at negative 2, positive 3. So our graph is going to look something like this, where these are the points where it actually cuts each other. So when you're doing simultaneous equations, you are literally looking at the points of intersection. And since it is a quadratic and a linear, it cuts at 2 points. Okay, that's how you do simultaneous equations, example 11 and example 12. Don't forget to like and subscribe. Our next video, we are going to do example 13, which is still simultaneous equations. See you in the next one. Bye-bye.